Hello, good morning or good afternoon. My name is Marco Meloni. I'm a consultant at Sophia's Group, now actually part of DSS. And we're part of the consortium in the CircThread project. Today I will talk to you briefly about Level Up, which is an H2020 project in which we are also participating. That is quite relevant to the CircThread project. As we will see now, there's a few similarities and parallelisms and probably some learnings that we could take and apply in the CircThread project. So, about Level Up. So Level Up is a large H2020 project. It received close to 14 million euros of investment. The project started in 2019 and runs until 2023. So we're about just over half the half-point mark at this stage. And the aim of Level Up is to provide a scalable platform covering the overall life cycle of both old and new manufacturing equipment. Also its aim as a project is to extend the useful life of large of major capital investments and large industrial equipment. It will explore ways of keeping this large industrial equipment in use for longer. As I mentioned just now, it's a large project. I think it's 28 different partners in quite a few European countries. We have the UK, Germany, Spain, Portugal, Italy, Greece, Slovenia, Czech Republic, and I think I'm forgetting one country here. So it's quite a big group of companies. The project comprises a series of elements. So it comprises different advanced manufacturing and digital technologies. It includes 10 protocols aimed at optimizing the functioning of the equipment and extending the life of these large machines. It's all connected through a digital thread, and that's one of the clear parallelisms with the CircThread project. And also it involves 7 pilot lines: metal machining, woodworking, automotive, caravanning, railway and aeronautics. So we're really applying the different aspects of the different activities in practice in these pilot lines. So the challenge and maybe the starting point for this project was that Europe is lacking an approach for a cost-effective, holistic and integrated application of circular economy principles in the digital uplifting of this factory capital investments. And with factory capital investments in particular in this project, we're referring to this large-scale industrial equipment. And with that in mind, the vision of the Level Up project is to enable modernization and digital transformation across the entire life cycle and value chain. So in other words, and what we're trying to do is to develop a holistic framework to optimize the utilization, maintenance, life extension through operations such as repair, refurbishment, eventually recycling. So this project is closely linked to circular economy objectives, of course. Now let's take a closer look at the different elements and things involved in the project. So there's a few, as I mentioned, advanced manufacturing and digital technologies. We have, for example, CPCization and digitalization. CPCization is a cyber physical system, so a physical system controlled by computer algorithms. We have inspection and non-destructive testing of components, and this could be, for example, radiography or tomography that allows to obtain detailed knowledge about, for example, the type of treatment that a component may need. Artificial intelligence, knowledge management systems, digital twins, and also end of life strategies. And these are well, and going into the actual actions that are being taken in the project. So for example, how are those technologies used? And there's 10 protocols that describe the actions that are being taken in the project, and these are modernization, functional diagnosis, inspection, refurbishment, disassembly, upgrade, repair, remanufacturing, recycling, and testing. And just to try to explain a little bit how like these new technologies and the protocols link. So for example, non-destructive testing allows to understand and obtain detailed information about the state of a specific component. Then you can have this knowledge is virtually represented in a digital twin of the physical component. That allows to do some modeling and understand, for example, what the best treatment option is, whether it's repair, refurbishment, or remanufacturing. And that's how all these digital technologies also can basically enable the life extension of large industrial equipment. And also, and then these, just taking it a slide back, these 10 protocols, which are actions that are taken, are say orchestrated in 8 strategies for sustainable manufacturing based on modeling, simulating, and forecasting the behavior. And these strategies are prediction, so prediction of operation based on evidence, diagnosing, early detection of, for example, of possibility of failure, and of course trying to maybe avoid this through, for example, prevention. We have also estimation, management, and this is something that I will mention specifically in relation to the work that we did at Sophius. Assessment, detection, and redesign and provision of feedback to have a redesign and improved performance, and also potentially leading to, for example, improved or refurbishment, remanufacturing, repair actions made easier. And so a key part of this project is the digital thread, and this is what weaves together the information of design, manufacturing, engineering, and supply chain, and it ensures that the right information reaches the right actors at the right time, so that it can enable this life extension and improve utilization of the equipment. And then there's also this concept of a certificate to guarantee the outcome of these operations. And now I wanted to take a moment to briefly discuss Sophius's contribution. And our role in the project was to try to understand the environmental implications of life extension decisions, support implementation, and support decision making as well. So we created 3 tools, an environmental assessment tool, looking at helping to support the large-scale equipment operators in the decision. So for example, should I refurbish my machine, or should I replace it? And there's a few factors that will be involved in this. from the impact of, for example, manufacturing new components or the remanufacturing operation to any changes in the efficiency of the machine that may come from this. We also developed a repair assessment tool that models the benefits of repairing certain components as compared with replacing them, and also a waste management tool to support the pilot lines in the management of any waste created. And in general, in the development of our tools, they're always quite flexible because we're working with a wide range of machines. I will describe them in a couple of slides actually. Be applicable in a wide range of scenarios. There's a lot of different components that can need replacement. So it was developing a tool that could adapt to all these different scenarios. And then finally, a very interesting part of this work is that we're integrating this environmental management tool into a decision support system that combines all the knowledge provided by the different actors in one central decision support point. And of course, we're doing this because we expect to have a positive impact. Now I'm talking again as a whole project, and the types of impacts that are expected are increased efficiency, increased reliability of the equipment, increasing the lifetime of the equipment, and also having a significant return on the investments. Now, as I said before, I just wanted to mention briefly the demonstrators or the pilot lines that are participating in this project. So we have Toshulin that operates a vertical lathe for precision metal machining. As you can see, these are large pieces of equipment, as you can see here, a person in comparison with the machine itself. There's also Marlenia, that's a company that produces wooden houses, and in particular in the context of the project they're working with a wood cutting machine. There's IPC, which is working on the refurbishment of a pultrusion machine that produces plastic bumper beams for cars. There's Isocon, which works on a plastic extrusion machine that produces components for caravans. Lucchini with an axle machining line producing axles for trains. There's ESMA that has a very large press that produces metal components for cars. And finally, Trimec, a metrological engineering company that's working with aeronautics components. And before closing, I thought it would be interesting to just briefly consider some synergies and differences between Level Up and CircThread. So first, the synergies. Both these projects are focusing on enabling the circular economy, and both include this digital thread of information. So I think I'm sure there will be plenty of really valuable exchanges that could happen in between projects in terms of how this digital thread is developed, and also what kind of information should be placed in this digital thread, what's useful, what can be used by the different partners. But at the same time, there are some significant differences. In Level Up, we're working with large or very large industrial equipment. Sometimes it's up to a few hundred tons for some of the machines, for example. While in CircThread, we're working with home appliances. This is not only a change in the scale, but also it means that some of the value chain actors are different. With home appliance, for example, we'll be involving consumers, while with large industrial equipment, we're involving businesses. So that's that can change the actors and also involve more actors and more people to consider. Well, that's the end of the presentation. If you would like to have any more information about Level Up, or if you think there's any other aspect that you would like to explore, please don't hesitate to get to me, to reach me, and I'll try to either understand that or put you in touch with the right person within the Level Up project. Thank you very much for your time.